In this video I'm going to review solving linear equations, and some of these questions are a little more complex than maybe just the simple routine questions that you've practiced over and over again. So let's have a look at our first one. So the first thing I'm going to try and do is get all my x's to one side of the equation and all my constants to one side of the equation. So since I have 5x's here and that's more than 2, I'm going to subtract 2x from both sides, so then that way I'm going to work with positive numbers. So if I subtract 2x from both sides, I'd be left with no x's on this side, and 5x minus 2x would give me 3x. Then I would still have the plus 15, and I would still have minus 30. Now, I want to try and get the x's all by itself, so if I subtract 15 from both sides of the equation, that will get rid of this. So 3x will be equal to, and then I have minus 30 subtract 15, which is minus 45. And then finally, if I divide each side by 3, x will be equal to negative 15. Okay, next we have some fractions. Now, when we have a fraction on either side of the equality sign, we can use the technique that we learnt in class, cross multiplying. So whatever's on the denominator on one side is multiplied by the numerator on the other side. So you can draw them in. And I can see that this is going to be 2 multiplied by all of that. And then the 5 is going to be multiplied by the minus x. You can't quite see my minus because I went over it when I was doing the cross multiplying. So I'd get minus 5x. We can expand this bracket. I'll just pause the video for a second. Okay, the brightness should be a little better now. So now I can expand this bracket. So I have 4x plus 8 is equal to negative 5x. Now, if I add 5x to both sides, this would become 9x. Still have the plus 8 is equal to, now if I've just added 5x to here, I've got nothing left on that side. Now, if I want to get rid of this 8, I'd have to subtract 8 from both sides. So I'd be left with 9x is equal to, because I've subtracted 8 away, minus 8. And then finally, to get the x by itself, I would have to divide both sides of the equation by 9. So you have minus 8 over 9. Okay, in 4, we get another example where we can use some cross multiplying. So whatever's on the denominator here can be multiplied by the numerator there, and whatever's on the denominator can be multiplied by that numerator. So I would have 4 by 4 minus x is equal to 5 by 3x plus 5. Then I can expand these brackets. So this will be 16 minus 4x, and this will be 15x plus 5 times 5 is 25. This time I'm going to bring all the x's to the right hand side and all the constants to the left hand side, so we can keep working with positive values. In terms of the x's, the constants are going to become negative. So if I add 4 to both sides, that will mean that 4x to both sides, that would mean that I have no more x's here, and I would have 19 x's on this side. And then, if I want to get 19x by itself, if I subtract 25 from both sides of the equation, then I'll have minus 9, so 19x would be equal to minus 9, and therefore x would be equal to, divide both sides by 19, so it would be minus 9 over 19. Okay, in question 7, let's get we need to try and make x the subject of the equation. So first I need to do something with this minus 5, so I'm going to add 5 to both sides of my equation. So 5 minus x over 4 will be equal to 13 plus 5 gives me 18. Now to get rid of this 4 on the bottom, I need to multiply both sides by the 4. So this whole thing multiplied by 4, so I'm left with 5 minus x, and 18 multiplied by 4 gives me 72. Then let's make x the subject of the equation. So currently since 5 minus x is equal to 72, so if I subtract 5 from both sides, 5 minus 5, on the left I would only be left with minus x is equal to 72 minus 5 is going to be 67. Then if I multiply both sides by negative 1, x will be equal to negative 67. Okay, now the next thing that I can do, I can go about a question like this in a number of different ways. So what I'm going to do is I'm going to get a common denominator on my left hand side, and then I'm going to write my right hand side with the same denominator, and then I can actually just equate the numerators on each side of the equation. So I'll show you what I mean. So I can see that the lowest common denominator is going to be 6. So if I multiply top and bottom of this fraction by 2, I'd have 2 by 5 minus 2x over 6. So all I've done is multiply the top of the fraction by 2 and the bottom of the fraction by 2, minus. Then if I multiply top and bottom of this fraction by 3, so 3 by 2x minus 1 over, and then 2 times 3 is 6, is equal to, now this is minus 4, I want to write it with a denominator of 6. So minus 4 is the same as minus 4 over 1. So if I multiply top and bottom of this by 6, I'd get minus 24 over 6. Now, why is this useful? Because essentially what I can do, and in fact I'll write one more step first, so I could write 2 by 5 minus 2x minus 3 by 2x minus 1 over 6, because we have the common denominator of 6, is equal to minus 24 over 6. Now, since I have the same denominator, I can actually equate the numerators. So basically I can say whatever's, because of this equality sign, I can say, since I know that the denominator of each is 6, whatever's on the top of this must be equal to the top of this. So I could just simply say that 2 by 5 minus 2x minus 3 by 2x minus 1 is equal to minus 24. And now we have an equation which we're familiar with solving. So let's expand these brackets and collect like terms. So 2 times 5 is 10, minus 2 times 2x is 4x, minus 3 times 2x is minus 6x, minus 3 times minus 1 is plus 3, is equal to minus 24. Let's collect like terms. Minus 10x, then I've got 10 plus 3, which is plus 13, is equal to minus 24. Now I'm going to subtract 13 from both sides, so minus 10x I'd be left with if I subtracted 13 is equal to minus 24 minus 13 is going to be minus 37. And then if I divide both sides by negative 10, x is going to be equal to negative 37 over negative 10. And since I've got negative and a negative, x is going to be 37 over 10.